Hello, and welcome back to the veritable meat locker that is the adjunct faculty office at Montclair State University. Let's pick up where we left off in Module 7. I think we just looked at Investigation 1. I just want to kind of review those ideas, and we'll get into exercises 2, 3, and maybe beyond if I can keep the software functioning. Okay, so the hope with exercise 1 was that, well, it was late when I made that video, but I was hoping to convey this idea that, for example, in part C of question 1, where if we ask the question, okay, if is it appropriate to simply look at this, the measure of this, my draw feature is not working, is it appropriate to just look at the linear measure of these arcs subtending this openness? And the answer to that question is, well, yes. In a world where every circle has the circumference of if every circle has this circumference, and we're considering openness subtended by varying arc lengths, then yes, it would be appropriate. But obviously, that isn't the case. Circles can be of infinite size. So, just to make that clear, if I were to take this subtended section and now use the same center of that circle, yes, we still have the same amount of openness described here, right? But the measure of this arc is clearly longer than this one. Okay, so now in exercise 2, we are presented with these string lengths, each of which represent a unit that is 1/12 of the circumference of each of these circles, 1/12 and 1/12. And when we take into account a unit of measure that incorporates or is related to the circumference, in each case, if I were to take something of this length, 1/12 of the circumference, and use that to measure this angle, we see that we can get, in C1, we can get 2 of them. And again, if I take this length here and use that here, that's 1, and here, again, we get 2 of them. It looks like I cut off part B of this question, which is really the take-home. I don't have it handy. Let's see what we got here.
This is a lot of problems I would like to talk about, and only so much time.
Okay, so yeah, part B of this question is could we use the measures of the 2 angles from part A by measuring the length of the arcs these angles subtend in a standard linear unit like inches or centimeters, is what they ask us in part B. And very important for you to see is that if I were to use a linear unit, yes, these arcs subtend the same fraction of circle C2 and circle C1 by virtue of our choosing a unit of measure that was, in each case, 1/12 of the total circumference. But if we were to just consider the measure of this arc length in C2 and in C1, clearly we're going to get different measurements. So for part B, we say no, same openness, but the arc measures The arc measures will differ. The arc measures will differ. So part 4 gives some resolve to what we just did in 2A and B, and our conclusion there that our conclusion or a conjecture we can make about a criterion that a unit of measure for the length of a subtended arc must satisfy is that it must be proportional to the circle's circumference. To the circle's circumference. Hopefully that's legible. Okay, and so just to drive the point we're making here in 4 home, I'd like to again call upon our protractor application. Hope this works. All right, we're in our protractor app now, and let's toggle our angle measure. So we're looking at 30 degrees of openness, and now let's see, I'm going to pull up the arc length. So if I extend the radius of this circle, note how I'm maintaining the same openness, the same fraction of the circle. The arc is increasing. So it's important to point out that so too is the circumference, and I believe we can actually see that because we have proportionality, that we're always going to maintain this ratio of arc to circumference of 0.08. Right? So to maintain the same openness, I need both the arc, corresponding arc, and the circumference to maintain this proportionality. Okay, and so with that little demonstration, we can describe what it means to measure an angle and be specific about the quantity one measures when measuring an angle and the type of unit one uses to measure this quantity. As we just saw in our protractor outlet, we need a unit that maintains proportionality or takes into account the proportion of arc length over the circle's total circumference. Okay, so in number 6, we have these fun exercises that ask us to experiment with this idea of using an arbitrary unit that takes into account the fraction of the circumference that is subtending a given amount of openness. And for example, in A, we're asked to use the unit of measure that uses 1/4 of the circumference as a means for measuring this this angle subtended by this arc, or the amount of openness we're describing here. So if we were to use 1/4 of the circumference, well, that would be 25% of the total circle. So that would be 1, and then it looks like we have about another half here. Okay, so we would say 1.5 here. If we were to use 1/6 of the circumference, well, let me just if I can erase these. Well, what's going on here? Let me go back to my, let me pull up my, there we go. All right, so now if we're going to use 1/6 of the circumference, well, let's see, that would be 1/6 of a circle. Well, 1/6 of the circumference of any circle is, if we thought degrees, would be about 60 degrees, so I don't know, roughly about there. I don't know, that's more like right there. I don't know, that's about a sixth. And there are 2-6 if we're to use a sixth of the circumference as our unit of measure. Oh, I realize we're still playing here. My apologies. So, in part 3, if we were to use a whole circumference, well, if we said there are 2-6 that represent this this amount of openness, then if we were to use a whole circumference as our unit of measure, then this would represent 1/3 in that unit. 1/3. Right, because this is 2/6. Part B, very important. What is the contrast? Well, we're not changing our units, but what are we doing? We are increasing the circumference of this circle. We're still looking at the same fraction of the circle. So the result we're going to get here, because we're taking into account the circumference in proportion to the arc, we're going to get precisely what we got in part A. We get 1.5, 2, and 1/3. And then C asks us to use eighths. So again, if we consider that's half the circle, and there are 1, 2, 3, 4 eighths and half, and then another eighth. So that'd be, use my stylus here. 1, 2, 3, 4, 5 eighths. There'd be 5 of them. And if I were to use 5/8 of the circumference as my unit of measure, well, I have 1/5 of the circumference represented by this measure. Let me just delete those. So this would be 5, and then of course if we use 5/8 as our unit of measure, this would be 1/5. And of course, if we're using an entire circumference as our unit of measure, what we have is 5/8 of the total circumference. Okay, and so in part D, we're asked to consider these 3 examples where if we were to change the radii, change these radius lengths to twice their length, well, maybe we'll use B, it looks like about twice the length, and ask, is this going to change our answers from parts A, B, and C? Well, I hope you all see that this arc is still subtending the same openness, right? So using units of measure that take into account the proportion of arc over circumference is not going to change the results we got in parts A through C. Okay, so I think I'm going to wrap it up there. This video has gotten a little long, over 14 minutes. When we come back, we will define a radian measure. We'll try and establish a solid understanding of what a radian measure is and why it's convenient. So, see you in the next video.